Hello, and welcome to Astronomy Daily, your Monday briefing on everything happening across the cosmos. I'm Anna.
And I'm Avery. It is Monday, the 25th of May, 2026, and we have a packed show for you today.
We do. Coming up, China makes history with a crew launch that breaks several records at once. NASA's Psyche spacecraft wows us with brand new imagery from Mars, and the sun served up a signal so bizarre scientists are still scratching their heads.
Plus, ghost particles from a cosmic monster, a stellar feeding frenzy in an orbit that's almost impossibly fast, and a surprisingly hopeful story about farming on Mars. Let's get into it.
China made history on Sunday night, launching 3 astronauts to its Tiangong space station aboard the Shenzhou-23 spacecraft. And this crew is carrying several firsts with them into orbit.
The Long March 2F rocket blasted off from the Zhuaquan Satellite Launch Center in the Gobi Desert at just after 11 p.m. Beijing time, sending the crew on their way to what China calls the Heavenly Palace.
The crew consists of mission commander Zhu Yangzhu, pilot Zhang Jiwan, and payload specialist Lai Kaiying, and it's Lai who's making the history books. She was born and raised in Hong Kong and holds a doctorate in computer forensics. She is the very first astronaut from Hong Kong to reach space.
That's a genuinely big moment, Anna. Hong Kong has been growing its contributions to China's space program significantly in recent years, with university teams developing instruments for upcoming lunar missions. To now have someone from the city actually flying, that's a real milestone.
And the historic firsts don't stop there. One member of the Shenzhou-23 crew will stay aboard Tiangong for a full year, the first time any Chinese astronaut has undertaken a 12-month mission.
The extended stay is connected to a fascinating plan for the follow-up Shenzhou-24 mission, due later this year. That mission will carry a Pakistani astronaut, the first international visitor to China's space station, who will spend a short time aboard before returning on the outbound Shenzhou-23 vehicle, leaving one of the current crew to complete that year-long stay.
It's a clever piece of mission architecture, and all of it is building toward China's stated goal of a crewed lunar landing by 2030. Every long-duration mission, every new crew rotation is laying the groundwork for those much longer future missions.
The new crew will also relieve the Shenzhou-21 astronauts who have been aboard Tiangong for more than 200 days, slightly longer than originally planned following an incident last year where the return spacecraft was damaged by suspected debris. They'll be very glad to see a fresh crew arrive.
Congratulations to Zhu Yangzhu, Zhang Jiwan, and especially Lai Kaiying on this historic mission. We'll be following their time aboard Tiangong closely.
Now, remember a couple of weeks ago we told you about NASA's Psyche spacecraft preparing to slingshot around Mars on its way to the asteroid belt? Well, the images are in, and they are spectacular.
NASA released the photos this week from Psyche's gravity assist flyby of Mars on the 15th of May. The spacecraft came within just under 2,900 miles of the Martian surface, traveling at more than 12,000 miles an hour, and its multispectral imager was working overtime.
The standout image shows the Huygens crater, a massive double-ringed impact structure nearly 300 miles across in Mars's southern highlands. Psyche enhanced the colors to highlight compositional differences in the dust, sand, and bedrock, and the result is genuinely beautiful, ochres and tans and pale blues against the ancient cratered terrain.
These images serve a real scientific purpose beyond the stunning visuals. They're calibration data for Psyche's imaging instruments, the first chance the science team has had to test them against an object larger than a few pixels. That's going to be crucial when the spacecraft finally arrives at its target.
And Mars delivered the goods dynamically as well. The flyby gave Psyche a speed boost of around 1,000 miles per hour and shifted its orbital plane, all without burning a drop of onboard propellant. The navigation team confirmed the spacecraft is now on a direct course for the asteroid, with arrival expected in August 2029.
Asteroid 16 Psyche, of course, is one of the most intriguing objects in the solar system. A metallic world that may be the exposed core of a protoplanet and potentially worth more than the entire global economy in precious metals. Though we should note that last part is very much a theoretical figure.
Still, it's quite a headline. Gorgeous images now, the asteroid itself in 3 years' time. Well worth the wait.
Here's a solar physics story that genuinely surprised researchers. Back in August of 2025, NASA's instruments picked up what initially looked like a perfectly routine radio burst from the sun.
Except it didn't stop.
Exactly. These Type 4 solar radio bursts, produced when energetic electrons get trapped inside the sun's magnetic fields, normally last anywhere from a few hours to maybe a few days. The previous record stood at 5 days. This one lasted 19.
Nearly 4 times the previous record. That's not a small anomaly, that's a completely different class of event.
The tricky part was actually tracking it, because as the sun rotates, different spacecraft had it in view at different times. A fleet of 4 missions pieced the picture together. NASA's Parker Solar Probe, the Stereo mission, the WIND spacecraft, and the joint ESA-NASA Solar Orbiter. Each observed the burst for several days across 3 overlapping windows.
So it was almost like relay baton passing across the solar system. One spacecraft would watch the signal fade from its perspective, and then another on the other side would pick it up again as the sun rotated.
Using data from Stereo, the team developed a new tracking technique that pinpointed the source, a structure in the sun's corona called a helmet streamer. These funnel-shaped features form when hot plasma gets trapped along enormous magnetic loops extending outward from the sun's surface.
And the leading theory for why this one lasted so long was that 3 successive coronal mass ejections within the same region of the sun essentially kept re-energizing the burst, like someone repeatedly topping up a fire.
The findings have been published in the astrophysical journal Letters, and the implications for space weather forecasting are significant. While the radio waves themselves are harmless, the magnetic environments that produce these bursts can also accelerate dangerous particles toward Earth, particles that can damage satellites and spacecraft. Understanding how these bursts work and how long they can last is directly relevant to protecting our infrastructure in space.
And with solar activity intensifying through the current cycle, the timing of this research couldn't be better.
Now we're going deep, very deep. 2 miles below the surface of the Mediterranean Sea, off the coast of Sicily, sits one of the most unusual telescopes ever built. It's called KM3-NET, and it doesn't look at light, it hunts ghost particles.
Neutrinos, subatomic particles so small, so elusive, that a light year of solid lead would only have a 50-50 chance of stopping one. Trillions of them are passing through your body right now without you feeling a thing.
Back in February 2023, KM3-NET detected something extraordinary. A neutrino with an energy of 220 peta-electron volts. To put that in context, that's more than 30 times the energy of the most powerful neutrino ever previously recorded. A ping pong ball dropping 1 meter carries about the same energy, packed into a single subatomic particle.
Scientists have been trying to work out where this particle came from ever since. And now, fresh research published this week in the Journal of Cosmology and Astrophysics points to a culprit: blazars.
Blazars are among the most violent objects in the universe. They're active galactic nuclei, effectively supermassive black holes that are shooting jets of plasma directly toward Earth from billions of light years away. They're cosmic particle accelerators on an almost incomprehensible scale.
If the KM3-NET team's interpretation is confirmed, that this record-shattering neutrino originated from a population of blazars, it would completely rewrite our understanding of how these objects accelerate particles. It implies that blazars can push matter to energies far beyond what scientists previously thought possible.
And the story isn't finished yet. KM3-NET is still under construction. This detection arrived when only a fraction of the final instrument was operational. As the detector expands, it should catch more of these ultra-high energy events, potentially narrowing down the source to a specific object or class of objects.
A ghost particle from the edge of the universe, decoded by a telescope on the ocean floor.
This is exactly the kind of story that reminds you why particle astrophysics is so extraordinary.
Our next story comes from MIT, and it involves one of the most extreme gravitational dances ever observed. Two dead stars locked in an orbit so tight, so fast, it almost defies belief.
We're talking about a binary white dwarf system. White dwarfs are the remnant cores of stars like our sun, extremely dense, roughly Earth-sized, but retaining the mass of a full star. When two of them end up orbiting each other at very close range, remarkable things can happen.
In this case, the two white dwarfs are orbiting each other with a period of just 8.56 minutes. To put that in perspective, the Earth takes 365 days to orbit the sun. These two stellar corpses are completing a full orbit in less than 9 minutes.
At that proximity, gravity becomes overwhelming. One of the white dwarfs is actively stripping material from the other, pulling it apart and devouring it in what astronomers call a mass transfer. It's essentially a slow-motion cosmic cannibalism.
Led by Emma Chickles at MIT's Kavli Institute, the research team says this gives us one of the clearest news yet of how ultra-compact white dwarf binaries exchange mass at such extreme orbital periods. Previous observations of these systems have been limited, and many fundamental questions about how violent mass transfer can get in such tight orbits have remained unanswered.
There's another dimension to this discovery that's particularly exciting for the future of astronomy. Systems like this one are prime targets for next-generation gravitational wave detectors, space-based observatories that will be able to detect the ripples in space-time produced by these ultra-compact binaries.
So what we're seeing here isn't just a fascinating stellar spectacle. It's a signpost pointing toward gravitational astronomy. The tighter the orbit, the more intense the gravitational signal. And at 8.5 minutes, this system is generating waves that future detectors should be able to pick up directly.
The findings are published in the Astrophysical. Even burnt-out stellar cores, it turns out, can be torn apart under the right circumstances. Space is metal.
It really, really is.
We're going to close today's episode with something that feels almost like science fiction, but is very much science fact. If humans are ever going to live on Mars long-term, they're going to need to eat, and that means growing food. But Martian soil, or regolith to use the correct term, is toxic, nutrient-dead, and about as welcoming to plant life as a car park.
Not for long if researchers from the United States and Brazil have their way. Their new study, published in Frontiers in Astronomy and Space Sciences, proposes a biological solution: fungi.
Specifically a group called beneficial fungi, organisms that have been promoting plant growth on Earth since long before humans arrived. The key players here are arbuscular mycorrhizal fungi, or AMF, which work by essentially acting as a microscopic extension of a plant's root system, dramatically increasing its ability to absorb nutrients.
Martian regolith is critically deficient in 3 things plants need above almost everything else: nitrogen, potassium, and phosphorus. It's also highly alkaline, perchlorate-laden, and lacks the organic matter that makes Earth soil biologically active. The researchers propose that AMF and a related fungal species called trichoderma could begin to overcome those deficiencies and transform the regolith into something biologically workable.
What makes this particularly interesting is that these fungi have already been tested in space environments. Fungal species have been used on the International Space Station, and researchers are building an understanding of how they perform under the kind of abiotic stress, extreme temperatures, radiation, nutrient poverty that any organism on Mars would face.
The team is candid that significant challenges remain before you're growing wheat in Martian regolith. Real-world testing with actual Martian soil samples, rather than simulants, hasn't happened yet. But they're optimistic, and they frame this approach as a strategic biotechnological tool for what's called in situ resource utilization, living off the land.
The concept being, instead of shipping soil from Earth, which would be extraordinarily expensive and logistically nightmarish, you bring a handful of carefully chosen microorganisms and let them do the terraforming at the microscale. Turn poison into farmland, one fungal thread at a time.
It's patient science, but it's the kind of patient science that makes long-duration Mars missions and eventually permanent human settlement imaginable. We'll be watching this research closely.
And that's our Monday edition of Astronomy Daily. 6 stories from across the cosmos, from the launch pads of the Gobi Desert to the ocean floor of Sicily, from the surface of Mars to the edge of the observable universe.
Thank you so much for spending part of your Monday with us. If you're enjoying the show, please take a moment to leave a review wherever you listen. It makes a real difference in helping new listeners find us.
You can find us at astronomydaily.io and follow us on X, Instagram, TikTok, and more at Astro Daily Pod. All the links are in the show notes.
We'll be back tomorrow with more of the latest from the cosmos. Until then, keep your eyes on the skies.
And keep looking up.